Hi, everyone. Thank you so much for joining us today for session BWP301, SaaS Operations in Action for Buy with Prime. Today, we're going to share with you some of the best practices that the Buy with Prime team has learned in operating multi-tenant services. And by the end of the presentation, we'll also share some sample code so that you can get started as well. My name is David Ramos, and I'm a principal engineer with Buy with Prime. Today, I'm joined by two great co-presenters, Joan Yum, Senior Solutions Architect at AWS, and Jimin Kim, Solutions Architect for Buy with Prime. As a quick intro before I get started, I've been with Amazon now for over 11 years. I'm not exactly sure where the time went either. Most of my time has been spent on projects with a machine learning focus. So I've worked on the Fire Phone, if anyone remembers that, Alexa, Audible, and most recently Buy with Prime. I joined the Buy with Prime team because I was really impressed by the technical vision. The way that we approach multi-tenant services and composability really enables some interesting use cases, as well as posing unique challenges as we learn to scale. And of course, I'm a Prime member, so I love using Prime everywhere. Today, I'll briefly go over what Buy with Prime is and a very brief overview of our architecture and multi-tenancy. Then Juan will come on stage and describe an ongoing mechanism that we use to build full confidence that we're enforcing per-tenant isolation of customer resources. Next, Jimin will speak about what metrics the Buy with Prime team uses before summarizing the different techniques we've shown. We'll have some time at the end for questions, and I'm a new dad, so I'm obligated to show you some baby pictures. So let's get started. Buy with Prime lets millions of Prime members shop directly from merchants' online stores with the trusted experience that they expect from Amazon. This includes fast, free shipping, a seamless checkout experience, and easy returns. Buy with Prime is available today for US-based merchants, and some of you may have already seen the Buy with Prime button on some of your favorite stores. Merchants can integrate Buy with Prime directly onto their website, either by installing a JavaScript code snippet to get the Buy with Prime widget, or for Shopify merchants, installing the Buy with Prime app for Shopify. We also offer a growing number of APIs and real-time event subscriptions. We want to meet our customers where they are and be as flexible with our interfaces as possible in order to aid adoption. Buy with Prime is a win-win for merchants and their customers. Prime members, like me, get to enjoy Prime shopping benefits and a familiar way to check out, while merchants can nurture customer relationships and build brand loyalty. So far, Buy with Prime has been shown to increase shopper conversion by an average of 25%. This data point measures the average increase in shoppers who placed an order with Buy with Prime when an available purchase option was available versus when the button wasn't shown during the same time period. Since we launched in April last year, we also held our first Prime Day event with our customers. In aggregate, merchants who participated in Prime Day activities experienced a 10x increase in daily Buy with Prime orders, and saw an 8x increase in daily revenue from orders during that Prime Day event period. And this is compared to the month before we announced Prime Day. So now let's bring our focus to how we actually provide this service to our customers. Our services are all multi-tenant, meaning that a single service supports many distinct instances of use. Ensuring that tenant resources are isolated isn't optional for us. It's mandatory to how we earn merchant and customer trust. So with that said, let me give a brief overview of the Buy with Prime architecture. This is just to set some context for the main topics of our presentation, which is multi-tenant data isolation and observability. So if you're interested in learning more, you can use the QR code in the top right in order to see our reInvent session from last year, which dives a little bit deeper. Buy with Prime embraces the microservice architecture pattern in order to achieve developer concurrency and efficiency. This lets us iterate quickly on new features in an independent manner across service teams. As mentioned earlier, we allow merchants to integrate with both our front-end features as well as our back-end APIs. This means that a merchant can either use the Buy with Prime widget as is, or onboard directly to the same data APIs that we use to power those experiences. This lets us and merchants both experiment with new innovations for the shopper experience. The first aspect of multi-tenancy that I'd like to mention here is that each of our services manage their own AWS accounts, and each of those AWS accounts manage multiple merchant resources. This cardinality lets the service teams operate independently while also being able to enforce consistent data handling, security, and configuration, as well as simplifying other aspects like logging, metering, and other analytics. Jimin will talk in depth later on how we get visibility in tenant resources across these accounts, which lets us identify trends and debug issues specific to either a single microservice or a specific tenant. Our microservices aren't developed in complete isolation, however. We do enforce some common data handling and communication standards in order to help manage tenant resources. One of these common standards is the tenant ID, a unique identifier that accompanies any activity associated with an individual tenant's resources on every Buy with Prime service. When a merchant onboards to Buy with Prime, we leverage CloudFormation to synthesize relevant resources across every microservice for that integration. We also generate the tenant ID as a custom resource and propagate that to each of those services, which they can use to then tag any related request or data element. This all happens behind the scenes for the most part. The merchant only needs to be aware of their tenant ID when they're integrating with our APIs so that we can operate on their relevant resources. So now that every microservice has these resources for each merchant and the tenant ID for those merchants, we have all the pieces in place in order to facilitate fine-grained access to each tenant resources via temporary IAM assume role sessions. Each service, powered by our identity service, can enforce that a request only accesses the data that is rightly scoped for the associated tenant ID. Again, this was just a cursory look at some of our architectural aspects. I put the QR code up there for the reInvent session from last year that dives a little bit deeper. And of course, we're happy to answer any questions after the presentation. Now I'll introduce Jawan up to the stage.
Thank you. Thanks, David, for the intro. Hi, everyone. My name is Jawan Yam, Solutions Architect here at AWS. I am super happy to be here on the stage with you today at 4 p.m. Vegas. Thank you very much for being here, and I'll make sure you have a lot of fun here with us. So David introduced how Buy Prime works under the hood a little bit and what our service does. But I'd like to ask you to take a couple steps back and really think about why you chose to be here. So it is about learning from Buy Prime's experience and example and how you can leverage these practices into your own environment, right? So I'd like to tell you the story why we chose to make this presentation. So I personally joined AWS first, then moved to Buy Prime. So I already had the AWS lens and decided to come back to AWS to meet the customers. So when I first came to Buy Prime, honestly, my mind was just blown away, because they were doing exact same best practices that we AWS SA tell to our customers to do, and in a very beautiful and elegant ways. And I was like, this is something we should definitely talk to our customers about more. And this is how Amazon teams actually do it, and this is something we can benefit other architects and developers out there. So these are what this presentation is about. And our philosophy here is we do not want any one of you leaving this room empty-handed, so we got a lot of cool samples out there, so we are excited to share this. But before we do that, I'd like to jog your memory a little bit about the operational excellence in AWS for Architecting framework. So this is basically about like running your workloads and designing your workloads to efficiently serve your business requirements without having too much of operational overhead. I do not want to go over every single icons over here. There are great presentations about this, so please check those out. but I'd rather invite you to some of the key points that we thought is very important to BWP3. So it is really about automating the task and continuously improving the process so that we can learn from our failures and never repeat the same problem that we had. So what we did here is, a couple of things. Since we are a very young business, we opened up last April in 2022. What that means is we have to roll out new business critical features basically every day. And two, we should be absolutely fault-tolerant in the sense that we are being basically infrastructure for our merchants. And we should do all these things while we keep the security as job zero, just like any other Amazon services. But these are not the end. Because we are software as a service provider, this brings additional layer of complexity. So we have to know what happens across the whole tenants and make sure every single merchants of ours experience the quality that we'd like to provide to them. And we should also definitely know their usage patterns and find out if there's any way we can optimize their experience based on their usage. So these are something we should definitely care on top of the normal operational excellence that we have for general AWS workloads. Once you put this all in one picture, honestly, this is a lot. So what I'd like to do here is we'd like to give you two digestive versions that BWP3 has for these practices of operational excellence. For performing operations as code, enabling our developers to roll out new features every day, while we keep the robust tenant isolation boundaries, we embedded this tenant isolation validation into our pipeline. So this will be the first topic that we will go deeper into. And the second is, just like David said like 5 minutes ago, we are a big microservice shop. And we have multiple different engineering teams that manages different microservices, of course, in different AWS accounts. So it was a little challenging for us to have very standardized way of having metrics, logs, and all these observability things at the same level across different teams. So we had to find a way to standardize this in a smart way. And the way how we accomplish this is using AWS CDK, the Cloud Development Kit. So we will dig right deeper into this as a second part. When you take a step back and look at these two principles we have, these all boil down into one thing, the confidence. So we know engineering team has built great things, but we want to really, really make sure that we are setting same uniform high standard across the whole team for our customers, because having the tenancy layer is absolutely complicating a lot of things. So we are very excited to go deeper into this. And without further ado, I'd like to go into this automatically validate tenant isolation part. Since this happens in part of the pipeline, I'd like to quickly go through individual steps that we have in BWP3. So if you are familiar with Amazon best practices of CI/CD, that looks fairly similar to this. So what happens here first is the source check-in. Let's say you have an application, and to make this one application to work, there are lots of things to work together to make this one application work. There will be application source itself, operation source, tool sources, IAC code, and all these dependency packages. And if anything changes in one of those, the pipeline kicks off. Then we go through the build phase and do all the fun build stuff, like unit tests, compile unit tests, static analysis, and all these things. And once we complete all these build actions, if everything succeeds, we move on to the pre-production environment. So for pre-production in BWP3, we have 3, alpha, beta, and gamma. For alpha and beta, we are mainly validating if the latest code is functioning as we expected. And in gamma, we do all this validation, and in addition to that, we make it a little bit more production-like. What I mean by production-like is we bring the same deployment configuration as production, and we have the same monitoring and alarm setup for production. And we also do the same continuous synthetic testing that we do for production. So across these all alpha, beta, and gamma, we run a variety of integration tests. So we validate our assumptions on the mocks and validate it works as we expected. And we put those into auto rollback window. So any of these tests fail within the predefined time frame, it is just going back to the previous version. So you as the software engineer have to really make sure everything runs within the defined time frame. And the start of today's show, the automated tenant isolation validation happens as part of the security integration test across different pre-production environments. Once all these integration tests succeed, we finally go to the one-box stage. So here what we do is we want to really make sure this new source is backward compatible. And what we mean by that is we want to make sure that they can be deployed alongside of existing source. So for instance, we need to make sure the new source is not writing any data in the format that current code cannot parse, because that will just simply break the whole system. So what we do here is we deploy the new source to a small subset of the whole fleet. So let's say one virtual machine or even single container, small percentage of Lambda invocation. We set this site by site and let this consume the traffic organically together. And let's say we are setting the time window of 1 hour and let these two stay together and run the synthetic testing and make sure we have the successful synthetic testing results and the monitoring metrics. And by doing so, we really understand that this new source is not making any side effects by itself or just sitting by next previous versions. So with this all one box stage, you finally hit the production and your new feature is out there. So throughout this whole pretty intense validation process, we decided to add this isolation validation as part of it. So you might now think like, okay, now we know how pipeline works, but how does this tenant isolation actually work in automatic way? So let's go a little bit deeper into this part. The concept might be a little foreign to you, but how we do these things are not necessarily rocket science. What we do here is we should firstly go over architecture vectors we have here first. So just like David introduced, we have control plane and the data plane for microservices. And the control plane holds the metadata for the tenant. And the actual important business data goes to the data plane database. So we have these two database dimensions. And to make sure we are allowing only really important people to access their own data, we leverage two boundaries. One, AWS account ID, and the second is tenant ID. So we use these two as part of the IAM awesome role session metadata and make sure we are getting the expected outcome based on individual scenarios. So with these IAM roles, what happens things in action is straightforward. So if this security integration test, this part of isolation validation part happens, we instantiate the test runner. Once this is instantiated, it assumes the first IAM role. Since we are having allow listed, non-allow listed AWS accounts, it starts from not allow listed AWS account, but saying, I'm G1, I'm giving G1's data. So in this case, it would be something like, I somehow hacked microservice endpoint of BioPrime, and I'm trying to access legitimate merchants' data, which is pretty possible. And of course, for reasons, this should fail, and our microservices are smart enough to know which AWS account they should allow or deny. This will get 400 exceptions saying access denied, and we move on to the next part of allow listed AWS account and not matching tenant ID. So we do create, read, update, and delete, and make sure all these things are covered. So in the second case, you can think of it as I somehow hacked into microservice of BWP3 somehow. And now I'm not happy with just G1's data, but I want David's data. And I'm saying, I'm carrying this ID of G1, but give me David's data. And this should obviously fail as well. And with the same error code saying 400, access denied exception. And finally, you get the positive case from allow listed AWS account and matching tenant ID, because this is most likely coming through a legitimate path that BWP3 approves. So these are pretty straightforward, right? It's just about being more meticulous about all the corners that you can imagine about these tenant activities. But I'd like to give you key 3 considerations of this test runner part. One is you should be aware of the tenant isolation boundaries for yourself and really make sure you bring those things into the IAM role. For us, it was AWS account and tenant ID, but it can be VPCs or ECS cluster or EKS clusters for you, or whatever choice of the boundaries that you choose. You have to bring those into IAM role policy as resource or the conditions, and you just really make sure you cover this. And the next part is definitely the data dimensions. In our case, it was just control plane and data plane. But if you have multiple different AWS databases to support this, you gotta make sure you cover all the data sources and different data dimensions and tables, and cover all the operations that your application can perform. And really make sure you're covering all the corners of positive cases and negative cases. But everything is always easier to be said than done. And again, the last thing we want from this presentation is leaving you empty-handed. So we put together this very simple implementation of the test runner that I have just described. So if you scan the QR code top right corner here, it will take you to the GitHub repository containing Jest test framework. So what it does is it assumes IAM role that you provide and tries to create, read, update, and delete actions against the DynamoDB table that you give. So this is fairly simple set. What we'd like to accomplish with this is giving you the right starting point. So you should bring this to your office and expand it out to the IAM roles that you actually have, and bring in your EKS cluster options, VPC options, and all these things as part of this IAM role section part. And let's say if you have secrets manager or different AWS databases, you should definitely expand it out to other APIs as well outside of DynamoDB, just like we did in the sample repository. Once you figure out those things that you'd like to test out, the next thing you should do is putting that into your pipeline. So let's say you have this kind of code pipeline for you. Once your build phase completes and the dev environment has the new version of source, what you can do is using code build as a test runner and run the test for you. And what it will do is store the results to S3 bucket. And you as a reviewer can hit approval and make sure they are safe in isolation part, move on to the next pre-production or even to production. So hopefully this equips you with some tools to boost up your confidence over the isolation boundaries. And I want to share this QR code once again. And please feel free to share your feedback, questions, any issues that you face. We are all ears, and we'd like to help you out as much as we can. So So with this said, I'd like to invite Jimin over to the stage and let her walk you through one of the most important challenges of BioPrime, the observability, and how we tackle this.
Thanks, Jiwon. Okay. So in the second half, I'm going to talk about observability in SaaS. Before that, before joining BioPrime, I was an AWS for 3.5 years, just like Jiwon. I primarily supported startup and ISV customers. Many of them were SaaS provider. So I want to see who are coming from SaaS company. Great. And who are the engineers? Great. So I believe you can relate to this content today. So one of the frequently asked questions was, what metrics should be monitored and what monitoring tools do I recommend? Well, in this session, I do talk about the metric we monitor and the tools that we use, but they might not be yours. So I want to emphasize why behind our choices and the benefits we gain. Let's start thinking about observability challenges, where since BioPrime launched in 2022, we grew fast, meaning that we have more resources, more servers, databases, meaning that we have more metrics to monitor. If you don't put clear baseline what is important from your business perspective, then you would often end up giving equal weight on all the measurable metrics, and it will result in alarm fatigue. And the second, due to the nature of microservices, obtaining observability becomes more complex. You need to track all the dependencies and maintain visibility across AWS account. Multi-tenancy also introduced additional layer of complexity here. Then, how does BioPrime handle these challenges? First, we utilize purpose-built dashboard. Tailoring dashboard to specific needs enable us to concentrate on critical issues and quickly gain an understanding in our services status. Second, we utilize CDK to standardize our observability configuration. Because each microservice is managed by all different teams, keep our configuration consistent is challenging. Let's take a look at some purpose-built dashboard we have. The first example I'm bringing here is critical system health summary, focusing on availability, latency, and traffic. Well, it would be common format of dashboard, and I believe most of you already have similar one, right? So let me show you how we utilize this. We hold regular operational metric review meetings, and first I transferred to BioPrime. I was shocked because of the large group and diversity. I expected some technical folks there, but actually VP is there, and directors from tech, and even from sales, and all the engineering teams, managers and engineers. As a large group, we invest a lot of time. So we focus on critical operational practices, and one of them is reviewing this dashboard. With that, we can facilitate a shared understanding about key events and key services status within a short time across various stakeholders. Defining well-defined dashboard is not just enough. So it's crucial to have a practice to regularly visit and review them. So we are having a traffic peak in the last 2 days, for example, where it's actually coming from Prime Big Deal Day on October 10 to 11. So it was not an issue. But in this case, we expect to have an answer about what caused the issue and what was the impact, and ideally, the action we took. The next dashboard I want to share is availability tracker. So being available is bare minimum baseline for a service. If not available, no one can use it. So we listed up all the microservices that we have, where I have only 4, but obviously there are more. Each line indicates availability goal and the calculated availability during the last 7 days, 13, 30, and up to 90 days. I said calculated availability. We use this equation to that. Let's break it down one by one. You might have heard about uptime. So calculated as the ratio of uptime to the total running time, typically yearly or a monthly basis. It's a common approach though. We calculate availability using the number of requests because it's more closely tied to customer actual experience. What does that mean? So if you measure availability based on the fixed time frame, 5-minute interruption at midnight is technically same as one during peak promotion hours, like Black Friday or Prime Big Deal Day. But in fact, the impact is not the same in reality. So we calculated using the number of requests. Then why do we exclude 400 errors? Are they a critical indicator for client-side issues? Well, that's right, but it can sometimes significantly distort the calculation. So consider this scenario if our system faced DDoS attack. Many of the requests would result in 400 errors. So 404 not found, 43 forbidden, or 429 too many requests. So if we include all the 400 errors, then it would distort the availability, making it appear more available than it is. So we remove them. On the other hand, we put 500 errors in the numerator. It clearly indicates where our system provides service. The same approach applies to everywhere in BWP3, and shopper checkout availability is not an exception. We put high importance on shoppers' experience, which is why we have a dedicated dashboard for them. You are looking at aggregated graph, both in weekly and 30 days view. So shopper checkout looks like a single workflow, but behind the scene, it involves many APIs from different microservices. So that is why we have a breakdown view together. If any of these API fail, then the shopper wouldn't able to complete the checkout. So if you click on the breakdown, the dashboard, then you'll see the complete list of all the APIs and the blurred top 3 availability drops. So the blurred top 3 APIs are actually having the most significant availability drop over the given time period. So with that, we can identify which API within specific microservices were unavailable and how that impacted the aggregated availability. As you've seen earlier, the monitoring timeframe in BWP3 typically spans from weekly to 30 days. So the short timeframe spots emerging trends and help us address issues quickly. Meanwhile, why do we have longer timeframe for the same metric? Some changes come so slowly that they might not be visible within a short-term view. So combining a longer time frame is an easy solution for you to prevent future potential issues. Let's get back to shopper checkout experience. Another key metric we care about is latency. So high latency, it can directly impact shopper satisfaction, but also has implication for availability, as it can result in API request timeout. To gauge the shopper checkout experience from their perspective, we split the checkout journey into 3 individual steps, and we measure the time in milliseconds. First, when shopper clicks the BWP3 button, they are prompted to log into their Amazon account. We measure the time it takes to the shopper to bring to the login page. In the second step, after shopper log into their Amazon account, we need to have the ship-to address to compute delivery promise date. And then payment information is linked in the second step. Here, we measure the time, how long it takes to generate checkout page by obtaining all these pieces of information. Once they complete the review, then they click the place order button. Then BWP3 start tracking the latency to complete the payment, and finally redirect the shopper to the order confirmation page. Breaking down the shopper checkout journey into smaller chunks, we can pinpoint any specific bottlenecks along the way. We have a dedicated dashboard to monitor the individual steps latency, both in P50 and P99. We have a specific target for them. P50 and P99 percentile, they are common approach to roughly measure users' latency experience. P50 represent the time, the median response time, where 50% of observation fall below. On the other hand, P99 represent the extreme response time, where only 1% observation exceed. So far, we looked at some purpose-built dashboard within BWP3. High-level summary, specific technical performance, and user experience. The data used there, like availability or latency, where the data comes from. And they are collected by each microservice team who owns the service, where it's natural for them to have the data because they need it to efficiently manage their service, right? But are we certain that all different teams are following same principle? So for example, do we know if they are using the same availability calculation? Or is there any missing metric? Well, it's exactly where CDK comes into play. We have defined CDK for BWP3 to spin up standard AWS resources that following our opinionated best practices. Our engineers from all different services collaborate together on a common set of best practices for BWP3. With this CDK, we can create a central repository that is now used by all the different teams. With this, we save 50 engineering years. Yes, I said that. So 50 engineering years. That's a huge amount. Another session titled Construct Your Construct covers how BWP3 leverages CDK for scalable architecture. And today's session will specifically look into monitoring CDK, which is subset of BWP3 CDK. Monitoring CDK consists of 4 different parts: dashboard, metrics, alarm, and logging. From now on, I'm going to demonstrate some CDK code snippets to give you an idea how these components are integrated within the monitoring construct. By the way, Jiwon and I released simplified version of monitoring CDK as an open source, so I will introduce later with more details. There are some basic metrics to be monitored. So for example, ALB and API gateway, they are recommended to collect HTTP 400, 500 errors. And in terms of compute, ECS Fargate, Lambda, they are monitored for CPU and memory utilization. Lambda requires some additional unique metrics like invocation, cold start time, or max memory use. Now, let's see how these metrics are accommodated into monitoring CDK. I'm bringing here API gateway example. Remember, we measure latency using percentiles, and they are represented as P50, 90, 99 latency, and integration latency here. Just to be clear, integration latency is the latency between API gateway to the upstream server, whereas latency encompasses this integration latency along with other API gateway overhead. So it represents the total response time. We monitor availability. Yes, it's not a native metric of API gateway. It's calculated custom metric using the equation we discussed earlier. To do that, we need number of requests and 400, 500 error count, which are collected by CDK together. Because metrics are predefined in CDK under the hood, we can mandate all necessary data is collected and measured in a consistent way. Here, API gateway metrics are exported as an interface, and with that, they can be consumed at higher levels like dashboard or alarms. Let's see how alarm is configured here, where metric has threshold and alarm is based on that. So from the CDK perspective, it looks pretty much same. But what do we do with alarms? So remember alarm fatigue I mentioned as observability challenges? So to mitigate it, we first clearly categorize the alarms based on the severity and if it requires immediate remediation from the engineers. If it does, we automate operational practices using CDK as much as we can. So for example, the CDK will automatically create a ticket in our ticketing system. It will be assigned to an engineer. And if engineer fail to resolve the issue within the given time window, then the severity goes higher and needs to be escalated. Major level escalation is also defined CDK, means automated. Returning to the support ticket that CDK created, it already encompasses all details about the alarms. So logs and the dashboard we need to look at and operational runbook. The runbook says specific steps I need to take. And the first thing I need to do is to confirm if the alarm is still going on and if there are real customer impact. For investigation, I want to introduce two powerful tools, Log Insight and Contributor Insight. Let's explore how they are incorporated into CDK. I'm bringing here a simple Log Insight query for application log. First, it filters log entries where logging type is labeled as error. The result will be sorted by timestamp in descending order, limited to 100 entries, and display log stream and logging message. Basically, this query is to filter out application error logs with timestamp, so we can narrow down the time duration and continue to dig into. So it's kind of common approach regardless of the kind of microservices. Creating log insight query in AWS console is not a difficult job, but this kind of query can be consumed any team, then we accommodate them into our CDK to eliminate manual effort from the engineers. Again, it's one of the cases how we saved 50 engineering years. Contributor Insight is another tool we often analyze and we often use to analyze high cardinality data. High cardinality, what I mean here is log contains many distinct values and dimensions. So if you look back our BWP301 architecture at high level, then each microservices are isolated at AWS account level. So account ID can be critical dimension in terms of dependency. Also, each microservice has multiple API, and as we've seen earlier, we need API level visibility. Also, we identify tenant using tenant ID. Obviously, we need tenant level visibility. So for example, when incident happens, then who got most impacted, for example. Let's see what we can do with Contributor Insight. It's showing top colors with server errors per API by tenant ID. If your service is monolithic running in a single server, then you can easily find top colors using some Linux command, right? But in BWP301 complicated architecture, how quickly can you find who they are with the tenant ID? And what are the error kind? Is it server or client? What API is that? And what about the pattern? Is it confined to specific tenant, or is a particular API generating server errors for multiple tenants? So Contributor Insight significantly simplifies such complex analysis. So for example, if you see actual tenant ID or API name from the graph, then you can immediately distinguish who are most impacted by server errors in which API. Contributor Insight were also defined in CDK. Let's take a look. So I'm bringing here a rule named top colors with server error by key. And I want to bring your attention to log group name. So FileLens is container log router for Amazon ECS and EKS. And EMF embedded metric format. It's a mechanism supported by CloudWatch. You can embed your custom metric in the form of logs. So without having to call metric API or creating metric filter on log groups. In our EMF, fault indicates server errors. So that is why you have filter fields with match operator to find fault. The key is to classify contributors, so who or what is impacting our system performance the most. The key here can be tenant ID, for example. In BWP3, tenant can be identified tenant ID. So if we put tenant ID in the key, then we can see which tenants are impacted by server errors. If we put AWS account ID in the key, then we can understand which dependency got impacted by server errors. So the specific rule or key filters might differ for you. But whatever they may be, you can simply analyze them using contributor insight. Here's what you can do today. So if you like our observability approach using CDK, you can start from our open source. To access the repository, you can scan the QR code. I know it's a little small. I have a bigger picture in the last slide, so don't worry about it. So let me briefly introduce what we have in the open source. The CDK has a library to generate custom dashboard and has some sample log insight queries and contributor insight rules. When you deploy CDK, it will spin up sample web application running on ECS Fargate. ECS Fargate task has two containers there. One is for app, so it has web application, and sidecar is file lens. So file lens will collect all the container log and send them to CloudWatch logs so they can be analyzed using log insight or contributor insight. The web application is fronted by ALB, which is configured to collect access log and store them in S3 bucket. So you can also see how this S3 bucket is securely configured. And the ALB's custom metric like HTTP error count will be accommodated into CloudWatch custom dashboard. Let's recap. The key takeaway from the content covered today. So in the first half, G1 introduced a test runner, which is embedded into our dedicated test stage of deployment pipeline, so that we can validate the tenant data is securely isolated and perfectly protected. And so we automate this whenever we release new code change. In the second half, I introduced our observability approach using CDK and how we enhance our observability as a result. If you don't know where to start, then your customer can be a good starting point from you. So what metrics you need to collect and what tools you can use. Once again, you can access our two open source through the QR code and the link. The first contains a sample test runner to validate permission using IAM session tag. So you can develop your own test scenario from there without having to start from the scratch. The second link is for monitoring CDK. You can find how monitoring components are defined and are related together. I hope you like these two open source projects, and if you have any improvement idea or feedback, please open an issue in GitHub. This way you can not only help us, but also other developers. Lastly, if you are interested in BWP3, then you can register yourself in the list. There have been other BWP3 sessions, but they've happened in the past. But if you're still interested, you can check them out later from YouTube. So here at Amazon, we are a data-driven company. I know it's late. Thank you for coming today, but please make sure you fill out the survey for us. Thank you for joining today. Enjoy the rest of re:Invent.